Hello everyone, today we're going to talk about the dot product, section 7.8 in our book. So the dot product, if we have a vector u and a vector v, we basically multiply the x values, right? The first component, the a component of a and v, and add that to the b component of u and v. So given u is 3, -2, and v is 4, 5, find the dot product of those two vectors. So u dot product v would just be, first of all, let's rewrite our vectors. And that is equal to 3 times 4 plus -2 times 5. Giving us 12 plus the -10, or a dot product value of 2. Okay, notice that the dot product is actually a scalar number. We're going to actually get just a number. We're not going to have our i's and j's, okay? It's strictly a scalar number, okay? Next, it might help us to know the angle between two vectors, right? So actually, how far apart are these two vectors? So let's find the angle between the vectors u and v given this formula here. So cosine of theta is equal to the dot product of u and v over the magnitude of u and v each. So dot product of u and v should be 2 times 4 and plus 5 times -3. Over the magnitude of u, okay, so remember that's equal to the square root of 2 squared plus 5 squared times the square root of 4 squared plus -3 squared. Remember, negative numbers squared are going to be a positive value. So when we simplify this, our numerator is 8 plus -15. Our denominator, and let me move that graph down a little bit. Our denominator gives us square root of 29 times the square root of 25. So when we go ahead and solve for this, we get -7 over 5 square root 29. Right? Square root 29 is not going to break down anymore. There's no perfect squares to go into it. And square root 25 is 5. So this is actually equal to the cosine of theta. Cosine of our angle is equal to -7 over 5 radical 29. And then remember, if we're looking for an angle, we take the inverse cosine. So inverse cosine of -7 over 5 radical 29 gives us an angle of 105 degrees, 105.1 degrees. Okay? So we have found these two vectors, the angle between them. Let me show you what we're actually finding. Right, so our first vector was 2, 5. 2, 1, 2, 3, 4. And that was vector u. Okay, so that's our first vector. Remember the components telling us basically the x and y coordinates. The second vector was 4, -3. Okay, and that was our vector v. What they're saying is when we find theta, that's really, this angle is 105.1 degrees, the angle between those two vectors. And that's pretty close. It's definitely an obtuse angle, and 105.1 is what we found that to be. Okay, next thing we may need to determine is if two vectors are perpendicular. And another word for perpendicular is orthogonal. Okay, so a lot of times on test questions, final exam, you'll hear, are these two vectors orthogonal? And basically all you have to do is the dot product, and if it equals 0, they're orthogonal or perpendicular to each other. If it doesn't equal 0, they're not orthogonal. So let's check A and see if they are orthogonal. Remember, that just means we do the dot product. So that's just going to be 3 times 2 plus 5 times negative 8, which gives us 6 plus a negative 40, and that gives us negative 34, which is most certainly not orthogonal. Okay, so that's all there is to determining whether or not two vectors are perpendicular. So let's check the second one. And again, we just do the dot product. So that's 2 times negative 1 plus 1 times 2. And that gives us negative 2 plus 2, which is 0. So these are orthogonal. Okay, simply finding whether they're perpendicular or not. Finally, the whole reason why we may want to do a dot product is to determine the amount of work done. Okay, and work is defined as the force moving along a vector D. So here we have a gentleman pulling, what do they call, a wagon. He is exerting 20 pounds of force on the handle, and the handle makes a 60-degree angle with the horizontal. Okay, so that's our typical 60-degree angle, right? It's measured from the x-axis. Find the work done moving the wagon 100 feet. So, first of all, we have to determine the force, then we can determine vector D, and then the dot product tells us exactly how much work is being done to pull that wagon. So, our vector D is the easiest one to determine, okay, because we started at 0, we moved to 100, okay, so the components of D is, what, 100 I, my x component, plus 0 j. I haven't gone up, I've only gone across, okay, so that's my vector D. From 0 to 100, I've moved 100 in the x direction, if you want to think of that, or east direction. Okay, then we need to figure out the force. Okay, so the force is going to be, okay, so this we got to think back to 7.7. When we want to find the components of the force, we know 20 pounds is acting on the handle, and we know the angle. So that's going to give us 20 cosine 60, and that's the I component, plus 20 sine 60. And that's the j component, right? The x and y parts. Continuing on, 20 cosine 60, we should remember, is 1/2. And that's all the I component. And 20 sine 60, we should remember, is radical 3 over 2j, the y component. So, the force, when we simplify as much as possible, 10I plus 10 radical 3j. Okay, just doing that multiplication straight across. So, I've got my D vector, I've got my force, now I can figure out the work. Is just equal to the force dot product with my D vector. So when I do that, my force was 10I plus 10 radical 3j. Dot product D, if we remember, 100I plus 0j. We haven't gone north or south, we've only gone east. So 100I plus 0j. So when I do the dot product, I get 10 times 100 plus 10 radical 3 times 0. Remember, when we're doing the dot product, we no longer have our I and j components. We're going to end up with a scalar number, right? Just a constant. Okay, so 10 times 100 is 1,000. Anything times 0 is 0. So this means the amount of force being done on that wagon is 1,000, and they call it foot-pounds of work. Okay, so go ahead and attempt the example problems in the PowerPoint and work on those chapter 7.8 practice problems.